Good afternoon, Madam Bong. My name is Elmaton.
My name is Christine.
And my name is Jessica.
My name is Brendan.
Today, we will talk about practical work 4. It's topic 3, bipolar junction transistor BJT. The objective of this practical work first is to construct the common emitter circuit. Second, to measure the current base IB and current collector IC. Third is to measure the voltage collector emitter VCE and voltage base emitter VBE. And lastly is to plot DC load line. So this is our BJT transistor circuit.
So next, I will explain the step-by-step procedure to measure voltage and current in BJT circuit. So the first step is we need to set the multimeter to DC voltage mode. Connect the black probe at E, click negative probe, and also the positive probe at C. To measure the voltage, we need to turn on the power supply and also record the voltage reading, as in the video recorded. So this is based on our practical work that we have done before this. And the result that we obtained is 1.61 volt. Next, we need to measure the current using digital multimeter. So the first step is we need to set the multimeter to DC current mode or milliampere or ampere. First, we need to move the red probe to the current terminal and disconnect the circuit where current needs to be measured. Then we connect the multimeter in series with the circuit. So to measure the IB, we need to connect in series with the base resistor as shown in the video. This is the example of the way that we can measure the IB. So this is the result that is obtained from the practical work, which is 48.8 microampere. To measure the IC, we need to connect the positive and also negative probe at the collector resistor, as shown in the video. And the result obtained is 10.5 microampere.
Based on a table 4.2 correlation of beta DC, also known as a current gain, represent the relation of the collector current IC to the base current IB. It indicates how much the transistor amplifies the input current. Conclusion step from table 4.1, I see 10.53 microampere and IB is 48.8 microampere, which is familiar. IC divide IB. 10.53 milliampere divide 0.04 formula of beta IC divide IB. Conclusion is 10.53 milliampere divide 48.8 microampere. And answer 215.16 milliampere. Second, saturation current IC formula is IC multiply SAT BCC divide RC. Based on the values shown, BCC is 5 volt, sorry, and RC 330 ohm. Calculation is 5 volts divide 330 ohm, and answer is 1.5 50.50 milliampere. Third, cut-off voltage BCC equal 5 volt. One, calculation of beta DC, also known as a current gain, represent the ratio of the collector current IC. Calculation step is from table 4.2. IC is familiar IC divide IB. Calculation is 10.5 milliampere divide 4.8 microampere, and answer is 215.16.
So next is the DC load line representing the DC operation points of the transistor. So firstly is the VCC equivalent to 5. And other than that, for the saturations is equivalent to 15.15 milliampere. Nextly is the ICQ. The point is 10.5 milliampere. And then last but not least is the VCEQ is equivalent to 1.01 volt. The Q point VCEQ is equivalent to 1.61 volt. Yeah, sorry for the mistake. And the Q point is connected same line within the ICQ and VCEQ. Yes. A part of that, I will explain about what is cutoff voltage. So firstly, is the cutoff voltage is the minimum voltage level at which a battery or device is considered fully discharged and stops operating to prevent damage from over-discharging. As we all know that cutoff region is IB equivalent to 0, then IC is also equivalent to 0. It is because of the transistor behave like an open switch. For silicon transistor, VBE cutoff is less than 0.7 volt. If VBE is less than 0.7 volt, we know that the base emitter junction is not forward bias. It is also no collect current flows. At cutoff, VCE is equivalent to VCC. Summary of the transistor regions are: cutoff is transistor off. Secondly is active, which we can apply in amplification region. Thirdly is the saturation. It is also, we call it as a transistor fully on. Lastly is the conclusion. In conclusion, we successfully demonstrated how to measure voltage and current using a multimeter and applied these measurements to analyze transistor behavior. Using the measured collector current, which is IC, and base current, IB, we calculated the DC beta B to evaluate the transistor current gain. We also determine the saturation current based on the supply voltage and the collector resistor value. Additionally, we identified the cutoff condition by observing that the transistor turns off when the base emitter voltage VBE is less than 0.7 volt. Thank you.